I hope everyone is well and that the second lockdown isn't affecting you too much. Maybe we'll just start by thinking again about the face-to-face classes that have been running. We had 2 people in the face-to-face class last week, which is fine, but we'd like more. I'm just looking up the file now to see.
Just had a look, Ben, if it helps. I've just had a look, and it's currently on 3 people for tomorrow. So, folks, Ben and I had spoken about this. We might possibly, if it stays underneath a number of about 5 or 6, we might cancel tomorrow and postpone it to the other week when maybe we can get more of you in. Ben, I hope that's okay for me to share.
Exactly. I think that's the plan we discussed.
So, folks, if anybody is interested in joining us, please sign up this evening so that we know, and we can then give advanced warning whether it's going ahead or not by the end of today's session. That would be helpful for all of us, I think.
The plan for this evening's class is that we want to talk about engineering drawings again. So we'll be building on some of the work that you've done already in design and practice. By engineering drawings, we mean quite specifically the 2D, the kind of thing you can print out and put on a piece of paper that shows people what your 3D model is going to look like. And everyone should know the basics of that from design and practice. And we're just going to go into a bit more detail and depth in engineering design and hopefully give you the tools to make this another part of your kind of engineering skill set. We were going to have a colleague come and join us as kind of a guest lecturer, and he was going to tell you all about BS 8888, which is the British standard for engineering drawings. He can't come, unfortunately, but he has given Alessio and me his information and slides, and so we're going to use that as the kind of basis for this lecture, if that's okay with everyone. So I think what I'll do is I'll just jump straight into that. And the first thing that we want to talk about, well, I'll go through the slides, and Alessio and I will just talk through them as we go, and then we'll stop and run a demo once we've got to specifically looking at first and third angle projections, which are things the words will be familiar from design and practice, and then in engineering design we're going to talk a bit more about that. So let me share my screen, and I hope you can see there the first slide. Just to scare you, there are 205 slides in this slide deck, and Alessio and I are going to go through all of them. We'll spend about 10 minutes on each slide, so you can work out for yourself what time you'll get to bed tonight. I'll go full screen. The really important stuff is in the first few slides here, and so that's where we want to focus. And then the rest, I've just tried to upload them onto the Moodle site so that you've got them as a kind of, it's almost like a reference textbook, where if you say, I really want to represent a gearbox in Fusion and then in an engineering drawing, and I don't know how to do that, you can flick through these slides until you find the information about gears and then take it from there. Okay, and these slides are all thanks to Barney Townsend, who is our colleague in mechanical engineering and design, and Barney's the kind of strongest CAD expert in the division, I think, and works closely with Autodesk. So, you know, you'll hear his name on some of the things that Alessio and I discuss, and he's a member of staff you might want to talk to in future if you're doing really CAD heavy projects. Just remember this code here, BS8888. BS stands for British Standard, and then 8888 is just the number that refers to engineering drawings. And you can get this digitally through the LSBU library, and we'll try to provide that link for you. Engineering drawings can get quite busy quite quickly, and one of the things that we're going to try and encourage is to find the right balance. The main thing actually to think about is not tolerancing or dimensions or the drawing block, it's the original representation that you go with, and trying to keep things quite simple on your engineering drawings is actually one of the main focuses of BS 8888. You can probably see on this, though, that there are just some things that are going to be complicated to represent. These curved markings on the surface of the front cover of this pager aren't going to be easy to explain to somebody else without putting a lot of dimensions onto the diagram. I would say we don't really want to see drawings that are this cluttered within this class, though. That's the kind of thing you might get to if you're really getting into the details of a very specific design. So this is what we wanted to talk about first, really, is projections. The first thing to say again is that this is sort of about simplicity, and that it says here the shape should be obvious to anyone who knows about drawings. What you want to do is make sure that anyone else can look at your piece of paper and immediately visualize your three-dimensional object. That's, if you've done that, you've done a good engineering drawing. That's the real key here. So the principal view is the most obvious and direct view, and we'll start from there. Often, if something is extruded up from a plane, then the principal view will be looking down at it, for example. So that's the most obvious view of something like this, if it's from sheet metal, and we can pretty much define it using that view. But this object here is harder to define using either a view from the top or a view from the side, so we need some other projections or views. And for this one, we'll need three views. So in design and practice, you'll have seen a discussion of an option that can be changed within Fusion, and that is the angle of projection. And in a couple of slides, there's a really useful visualization for this, and that's where I want to get to. I don't think we'll get a lot from these pictures, but this is what we want to talk about before we get into any demonstration. So for first angle projection, you imagine a box around the object, and then it is what it says, rays of light pass through the object to fall on the box behind it. So it's kind of the shadow. First angle is the shadow that the object would leave on the box. And then you unfold that box, and that is your first angle projection view of the object. So just to go back, I'll leave these blue arrows on, but the three shadows that are cast on the box are this one here, this one here, and this one here. And then again, we unfold that box and we end up with this picture. So it takes some slightly tricky three-dimensional visualization to see how you end up with this two-dimensional representation, and that's going to be a consistent theme of some of the stuff we talk about. So what's different with third angle? Well, we have the box again in third angle, but this time imagine that the box is a fish tank and you have to draw what you see on the walls of the fish tank. So instead of seeing the shadow, we're seeing the front face on the walls of the fish tank, and then we do the same thing again, unfold the box and see what we end up with. So you get a slightly different projection between first and third angle. I think we'll stop there for the time being on this set of slides. I'll just go. Yeah, let's go.
I'm so sorry about that. I was just clearing my throat.
Oh no, that's fine. Let me just go back, and I'm just going to show the first angle projection again, which looks like that, and the third angle again looks like that. So I'll encourage you to go and have a look at the slides in your own time and compare them directly, but the relative of the three views have changed, and also what we actually happen to see in each of the three views has changed. For example, this cutout here is completely visible if we look at the object and draw on the wall of the fish tank. But if we look at the shadow of the object, that cutout will actually turn out to be, I was going to say a dashed line because it's invisible, but there it is as a solid line. So don't trust a word I say, try these things out for yourself, I think. I would have that as a dashed line because it isn't seen from the shadow of the object. The good news is Fusion will do all of this work for you. And it's just important that you know there are these two projections, and that the very important thing to know, I guess, is that they're used in different places. So the ISO standard, which is typically used in continental Europe, has first angle projection as the default. And the ASME standard, where the A stands for American and I can't remember the rest, is the standard they use in the US, and that typically has third angle as a default. It doesn't really matter which one's the default, but you want to choose one. And in LSBU, because we use Fusion, which is an American standard, we use third angle projection as the default. And so one of the first things we'll be doing is changing the ISO template so that it uses that third angle projection. Alessio, anything to add on that?
That was great, Ben. Thank you. I think in the demo we're about to start, everyone, we'll remind you how to change the standard view in Fusion to third angle projection. It won't take long actually to then do another version of that drawing, and we could actually create it in first angle, just so you can see a little bit of the differences. So that's something that just occurred to me, Ben. We could do that.
Yeah,
I'll dimension one up a little bit more detail, but the second one just to do a comparison, and then we could look at the two by flicking between the two screens. So I hope that might just further embed what we're talking about here, folks. Shall I move on and run the demo, Ben?
Yeah, that sounds good.
Okay, everyone. So what I'm going to be basing the drawing exercise on for this particular demo is on the 30-degree adapter. So feel free to, if you want to, feel free to open up your adapters if you've got them saved on Fusion, so that you can maybe run this alongside me as I'm going through it. The first thing that we're going to do is just to remind you of how we confirm with Fusion which angle projection we want to create for our 2D drawing. So what we need to do is just change a setting in the preferences. So the way we do that is open up the model. That's your first vital step. So this is the part that we're going to create the 2D drawing on. And just in the top corner, we're going to click on our name or initials, and we're going to select the preferences option. So second one down. And what we then want to do is select drawing. So somewhere just below the general tab, you'll find a drawing option, because that's the setting that we want to change. It's something on the drawing options that we're going to shift from. So the standard that we want to change is noted here. So we want to select ASME, and you'll see that in doing so, I'll just go back. So initially there wasn't any specification down here in terms of the projection. The text below will change as soon as we shift to ASME. So once we select that, you'll see that in grade boxes you should see third angle. Now there is one thing that we do need to change, and it's the units. So let's just double check. So we can actually override worrying too much over nothing. So the units, actually, we want to inherit the units from the design, but just to double confirm that the units do come in millimeters and aren't shifted to inches, we should always just double check that that's set to millimeters as well. So once we're happy with our third angle projection, we can apply. The other thing that I find sometimes a little bit frustrating is I like using A4 sheets of paper, A3 sheets of paper. They make much more sense to me than these letters. So another alternative to shift this to third angle, but also to have sheet sizes that we're more used to, is we can also shift the standard to ISO, but then we can actually overwrite the projection of the angle. So if we override the tick box here, we can change that to third angle. And so there we've then got the option of selecting A4, A3 sheets of paper if we want to. And at the same time, we've got the third angle projection that we're looking for. So either way is absolutely fine for your e-portfolios. Again, that's just a personal preference there. Ben, I hope I'm not giving some bad advice there to students.
No, that would be exactly my advice too.
That's good to hear. That's good to hear. So once I'm happy, folks, I'm going to click on Apply and OK, and we're ready to insert this into a drawing. So just to remind you how to do that, we now shift from our design workspace into our drawing workspace, and we select the From Design option. We will just verify that we want this on either an A3 or an A4 sheet of paper. Let's go for an A3 just because it gives us a bit more space. So I'll OK that. Now, depending on your processing power, this could take a few seconds, so just be a bit patient. Make sure you don't start clicking on the page while the part is being brought in. So Ben was talking about principal views. So the principal view, just to remind you, is the main view that at a quick glance would tell a viewer of the drawing what the part looks like. So just a quick question to you all. Do you think that should be an adequate principal view that we're bringing in there? Or do you think an alternative view would be more clear to a viewer of the drawing at first glance?
What's the alternative view?
So the principal view is the first view we're bringing in. So at the moment it's coming in as a front view. And what really I'm asking is, do we want to change that front view to something else? So let me show you, we've got some options here on the side. So if we wanted to, for example, we could bring in the principal view to be the top view. Or we could bring in the principal view to be the left view. So as a default, it came in as a front view. So having looked at those three options, which view do you think would be a best choice for a principal view? Any thoughts?
I think angled view should be nice to see.
Sorry.
Angled view, like side.
The angled view, yeah. I agree. I'd be inclined from experience to bring in something like the left view, where you can see a bit of the angle. I think that's a bit more informative than the front view. So the front view, there's nothing wrong with it, but we don't really get too much of a sense of the angle of the top. We get some hint at it. So this is what will come with practice, is you'll instinctively know what the principal view should be on a 2D drawing. So for this particular part, I would probably select that side view, the left view. The next thing to choose is the scale that you want the view to come in at. So it's currently set to 1:2, and wherever possible, it's generally good practice to bring in the part at a scale of 1:1, wherever possible. But I think setting it to 1:1 is probably going to give us very little space on the A3 sheet. So given that, let's assume in our company, we've got an A3 printer, we don't have anything bigger, I'm going to select 1:2, and I'm going to plonk in the middle of my sheet my principal view. And at that point, we've got options in terms of the style of that view. So we can bring it in shaded so we can see some of the material. But generally on 2D drawings, we want to keep the visual style to visible and with some hidden edges, generally speaking. So let's click on OK and let's see what that looks like. So the hidden edges are the hints at what's going on inside of your 2D drawing view, the dotted lines. Okay, so if I double click on that view and just show you what it looks like without the hidden edges, it looks much simpler, but then we'll have to do a lot more explaining in different views to try and get the point across to, say, a manufacturer of what's actually going on inside this part. So generally speaking, visible with hidden edges is the better choice here. We now bring in our projections. So just to remind you how we do that. So up here at the top, we've brought in our base view. So generally we kind of work across the toolbar generally. So we're now going to project some views. So if I click on the next option, projected view, this might start to ring a bell from Design and Practice. So we click on the parent view, the primary view, and then as you move your cursor, what you'll start to see is that you get previews in third angle projection either side of your principal view. So I'm just going to bring in now, well, I've got a decision to make really. Do I want to bring in the front view or the back view? So when making decisions like this, I suppose what you need to consider is that too many views is generally overkill. So there's not much benefit in having this view here and this view here. There's very little difference between them, and the main difference is at the top, and you'll probably dimension what's going on at the top in the principal view you've brought in. So again, from experience, I've generally found that the front view would be a good view to now bring in. So I'm going to just click on my screen and it will bring that view in. Now notice I'm still in projected view mode, so I can continue to add additional views. So I'm aware that I'm able to dimension most of the dimensions for this bottom view that you're previewing on screen from the two views above. So if I wanted to dimension just the square base, I could do so on the side view and on the front view. So I've got my kind of X and Y dimensions there. So really there's very little point in bringing in this additional view that's down here, because the only thing really I'd be able to dimension is the base. Having said that though, we need to think about what information we do want to provide to the person viewing the drawing. And I suppose the thing that's quite difficult to get from the two views above is the location of the 4 holes that are on the base. So with that in mind, folks, I can't actually see all 4 holes on the base in this view up here. And so it makes more sense to show the view down at the bottom here, because then I can actually dimension those 4 holes on the square base. Okay, so what we're always thinking about when we're positioning views is what extra information are we providing that the other views can't? And there is a point where you do get too many views. So I would suggest that the top view that's currently hovering now is probably not needed. I might change my mind later, but at the moment I think it's probably not needed. So at this point I'm just going to press enter on my keyboard, and that will bring in my 3 views for this particular drawing. Now anybody's ever struggled when moving these views around, remember that the first view, the principal view, is probably the view you should move first. So for example, if I wanted to move this view up, I can't actually do that because it's locked onto the principal view here. Likewise with this view here, I can generally move it up and down, but I can't move it side to side because it's locked onto this view here. So generally speaking, your principal view is the view you should move first. And the idea is you want sort of equal space, as much equal space between the views as possible. Okay. Now, if you find that any of the views are starting to look a little bit confusing, you can potentially change the appearance of the views as well by double clicking on them and then selecting selecting different styles at the top. But let's leave everything in the same view style, which is the visible with hidden edges. This is more of a reminder. Once we are ready to start dimensioning, bearing in mind that we want to kind of position the views first before we do anything else, we've got the option to create section views, which is where we cut through our parts. So we can do that using a section view. So let's do that next, just to remind you of how we create a section view. So let me move these views over to the left. I'll move this view over to the center, and it might be useful to create a section view that's down the middle of this view here. So if there's any misunderstanding by, say, the manufacturer of what's going on inside this part, we can clarify that detail by sectioning this view here. So let's put in the section view. We'll click on section view, and we're going to click first of all on the view that we want to section. So we'll click on that view, and then we'll get a preview of section AA. So you see that arrow with the letter A, that's the top part of my section line. And because I want to center it on this part, what I'm going to do is just find a midpoint, and midpoints generally are symbolized with triangles. So once I hover over the part and I see a preview triangle, I know I'm on a midpoint, So I just want to hover from that midpoint and just raise my section view a little bit higher so I can see it. And then I click once. Then I'm going to click twice down the bottom and make sure that I'm outside of the part, because the section view will stop wherever that second arrow is. So because I want to section the whole view, I'm going to go beyond the outer boundary of the part. But if I wanted to show a little partial section view, I could finish the section view up here. So I click my second click here. And now this is the point that often goes a little bit wrong. So at this point, I've clicked twice, and all I need to do is just press enter. So I just tap enter on my keyboard, and what will start to happen is the software will generate the section view. So you can see a preview of it on the side there. Okay. So once I'm happy with the view that I'm previewing, I then position it somewhere on the sheet. So I click and I tap it. And there's two things that will symbolize that this is a section view. First of all, you get the section AA text at the top. And secondly, you'll also get the section lines through the part. So that symbolizes that if we cut down the part, if we imagine cutting down the part virtually, and then we have a look from this side, this is the view that we would see. So that's our section view. Now, if we move across to the next icon, just to remind you, we can also provide detail views. That's where we enlarge particular areas of a drawing where maybe we've got some really fiddly detail. So if we want to just specify with a slightly enlarged view somewhere on the drawing, some fiddly little details, we do that using detail views. So if we click on the detail view option here, so let's say, for example, we want to provide the dimension for this hole or the center point of this hole to, I don't know, the edge of the shape. We want to show that a little bit larger. So we select the area where we want to create our detail view. So I want to create it around about here, in this area here. So what I'm going to do is just click, first of all, the parent view, and that tells the software the section view is going to come off of this view here. And then secondly, you want to click a center point. So if you imagine a circle is going to be drawn, so what I'm about to click now is the center point of the detail view. And you'll see that I can then move my mouse, my cursor, to create the detail view. Now, don't fall into the trap of creating the detail view too large. So you just want it nice and cute around the particular detail that you want to show off. So it's this careful balancing act of you don't want to have it too small, but at the same time you don't want to have a whopping big detail view circle on your drawing. So something about that size is appropriate for what we're about to show. So once I'm happy, I click and I'll start to get a preview of that detail view appearing on screen. Now, the interesting thing is with detail views is we can really position them wherever we want on our sheet. So we want it generally closer to where the detail view original is. But if you're tight for space, there's nothing wrong with positioning the view a little bit off of the bottom of the sheet. But I have got space, so I'm just going to position this detail view up there. And notice that while the rest of the views are set at a scale of 1 to 2, this particular detail view is set to 1 to 1. So this is larger. So these are half scale, and this is a full scale version of the detail view. So once I'm happy, I click OK and just give the computer some time to put that in. Be mindful that we don't want any text to go off the edge of the border. We want to keep text within the border of our drawing. So with all views, we can move things by click and dragging the the grey box that's in the middle of each of the views. So likewise on the text, if you click on the text, you're looking for that grey box to then drag onto the sheet that you're creating the views on. Once we're happy with our views, then start to do a couple of things. We can either start to dimension the drawing. So we've got our dimensioning tools here. It's up to you, but I also like to add things like center marks wherever we've got any holes, and also center lines where we've got symmetrical or symmetry on parts. So just to remind you of how to do that. So the views, there's not much symmetry going on the left view here, and likewise on this side here, but there's definitely some symmetry going on in this front view here. So for that reason, center lines symbolize, well, two things: symmetry, but also wherever you've got a hole. So if I select the center line option, and then I click on the outside edge of this tube and the other side here, you'll see that Fusion gives us this nice center line in the middle of our view. Now, if you find that it's a little bit too long, like in this instance, remember we've got control over all of these things. So if you click on the center line that's put in, you can actually drag the center line upwards a bit. So if you feel that it's poking out too much down the bottom, we can move that if we want to. A pedantic point, but worth pointing out. With holes, if we're looking at holes from the top or the bottom, with 2D drawings, we always symbolize holes with center marks. So that tells the person viewing the drawing that that's a hole and it goes all the way through the part. So if we click on the center mark option, and what we want to do is we want to try and pick out the hole itself. So once you click on the outside hole, you'll see that your center mark starts to show on the drawing. So let's just repeat that 3 more times. So we've got our center marks. Now, this is an interesting one. On the side view of a hole, we don't add center marks. Firstly, because the software won't let us. But again, going back to BS 8888, if we select the center line option, we can notify somebody who's viewing the drawing that this is a hole by also clicking on the 2 sides of the hole and adding a center line through it. And in fact, while we're here, let's do the same on this top view here. And we can do the same on this view here. And we can also do it on the threaded holes down at the bottom. So if I click the outside of my screw threaded hole and the other outside here, we've got a nice center line that's put in to tell somebody viewing the drawing that that's a hole. So once we've got things like center line, center marks, etc. on the drawing, we can then dimension. So we've got our dimensioning tool here. So if we click on dimensions, remember we want to try and get somebody to be able to read this drawing and create it. So imagine they're creating the part. So we want to kind of provide as much of the essential detail as possible. So this is where we'll leave you to have a little bit of, I guess, freedom, but also to initiate common sense in terms of what dimensions you want to include in order to describe the part as fully as possible. Oops, sorry, my computer froze a bit there. So it's this careful balance of taking each of the components one by one in turn and just asking yourself, well, what information do I need in order to create that part? So for the square base, obviously I need the width and the length of it. I'll also need the same for the center to center location of the holes. Let's do the same up here. I need to know what that radius is on the outside as well. I need to know how thick this is. So I can't specify the thickness of the base on this view, but I certainly can on the view above it. So somebody reading this drawing would know, right, so this is the side view of the part, and this is the view if I was looking underneath it, down here. So although I haven't got the 100 by 100 up here, I do have it down there. And that's the other thing with engineering drawings, folks, that you don't want repetition of dimensions. Okay, so you only want to show a dimension once. So for example, because I've got this 100 here, there's no need for me to include it here because the two views are related. The distance between these holes, these threaded holes, I don't need to include that here because I've got it down at the bottom. Okay, so we avoid repetition of dimensions when it comes to dimensioning the different views. With any 2D drawing, remember it's important also that we complete the title block as fully as possible. So Fusion makes this nice and easy. So as part of its default sheets that you can use, you can edit this set of title blocks very easily by double clicking on the title block itself, and in doing so you want the text to be highlighted in blue, and so then you can start typing the different values for this particular part. So being in engineering, our department is ENG, technical reference, let's say engineering design. If you go over the size of the box, that's okay, because as soon as you click onto the next box, Fusion is clever enough to squeeze that text into the area that you have double clicked on. So one by one, the idea is that you fill this information in. Remember that we can also include a logo, so it's always good practice to include company logos on drawings. So let's do that. So if I just finish that, and in order to insert the company logo in this area here, we go to Insert at the top, an image. I think I do have the LSB logo saved, so let's try and find the latest one. There we go, LSB logos. And so I'll get a preview of where to position this particular logo. So I want it to be contained within that area. So once I place the image, what I might need to do is just have a bit of a tweak with the scale. You've got your X and Y coordinates as well. So you'll notice that this is skewing ever so slightly to the right. So to get that a little bit more to the left, I've got to play with my X and Y coordinates here at the top. So -2. In terms of height, it's probably okay. So yeah, I'm happy with that. So if I wanted to, I could reduce the scale or increase the scale. If I wanted it smaller or bigger, I click OK. And so that's my title block updated. Just before we have a look at the difference between this and first angle projection, and what we do encourage you to do for today, folks, we'll give you some time to finish these off, is produce the drawings as fully as possible with as many dimensions as possible. Note that you can also include notes as well. So that's an important thing in 2D drawings. So sometimes you might want to add a note. So for example, when you're providing information on chamfers, we can either dimension the chamfer, but it's just quicker. BS8888 will tell you how to do this in the appropriate format. But if you click on the particular edge, we can tell the viewer that, for example, is a 2 by 45, and I want to add a degree symbol. So under symbols here, I've got a range of symbols, so I want the degree symbol after 45, and then I can just add a note like that just tells anybody viewing the drawing that inside chamfer is 2 millimeters by 45 degrees. Are there any questions, folks, before I show you the difference between these views and first angle projection? Let me just double check how we're doing on the chat. Any questions so far, everyone?
Just one thing to fill you in on, Alessio. The part-timers arrived at about 6:45, so I've suggested that I think the best thing to do is for all the part-time group to follow along as you're working through it, and then the lecture's been recorded and you can go back and look at just the details from the start of how things work. But I think one of the nice things about engineering drawing is you can build up the understanding bit by bit, and you actually can come in halfway through watching it and still get quite a good understanding of what Alessio was doing.
Absolutely, absolutely. Okay, so let's just switch back then to Fusion. And don't worry, I'm not going to go into as much detail, but I just want to show you the difference between third angle projection and first angle projection. So what we'll do is, let me save this first of all. So we'll call that engineering adapter third angle. Okay, I'll come back to that. So let's do this again, and let's shift this to a first angle projection. So what we'll do is just change our options in the top corner again, our preferences. So we start by opening up our 3D model that we want to create the 2D drawing for. Then up at the top, when we click on our initials, we shift to preferences, and let's just have a change here of our drawing. So let's keep that as is, and let's just change that to first angle, and we'll apply and say OK. So we'll move over to the design workspace into our drawing workspace. So click on design, down to drawing, and from design. So let's stick to an A3 sheet again. So click on OK. And let's do what we did before. So we're going to shift from the front view for this particular model to a left view. And let's just position that. Click on OK. Okay, let's see if the projections now update. So if we click on the parent view and we position, in fact, let me try and try and remember the views that we added in the previous drawing. So this would be the front view on the other drawing, and this would be the bottom view on the other drawing. I believe those were the three views. So if I just tap enter, like we did before, remember we're moving views around, always start with the original principal view. So we click on the view itself, and then we click and drag on the grey box that we have on screen. And then I move the other views afterwards. Okay, so let's just do that now. I will now add the section view. So we've done the projected views. We'll move on to a section view. So same as before, we're going to section this view here. So I click on the view itself, zoom in, lock in on a midpoint, but don't click just yet. I'm going to just move my cursor upwards so I'm outside of the view. I then move down again so that I'm outside of the view. And then I'm going to press enter to get the software to generate the section view. And if I remember correctly, on the other drawing, the third angle projection drawing, we had this orientation for the section view. So let's position that and click OK. And let's try and get all of this onto one single sheet. So let's move some of these views along. Okay. And just for the sake of completion, the detail view is the only view that really doesn't change that much. So let's just add the detail view as we did before. So click on the parent view, click on the center of where I want the detail view, create a bubble around it, not too large, and then let's position the detail view just above it. Okay, let's just save that. So let's call that first angle. So how we then dimension this and add the center marks and center lines is exactly the same, but it's just to do a comparison. So here, this is third angle projection. So if you imagine we're looking at an object from the front, this view here is what we would see if we looked at the object from the right. This view here is the view we would see if we viewed the object from the left. This view here is the view that we would see if we were looking at the bottom of this part here. That is slightly different to first angle projection, where it's that projection of shadows that you've got to try to imagine. So if this was our principal view inside our box, imaginary box, and we've got some light that's being projected from left to right until it hits the object. On the other side, that's the shadow that we would see. And likewise, I've got to think about this carefully now, if we are projecting light from the bottom, that's the shadow that we would then see on the box. As you can see, folks, I struggle still to this day with first angle projection. But given that my industry work was all third angle projection, I'm making poor excuses up, but yeah. Generally speaking, that's the difference between the two. And if in doubt, the slides will just remind you of that difference. One of them is projecting shadows in your transparent box, whereas the other one is the fish tank, where if you view the fish tank from the left, from the right, from the top, that's the corresponding view you'd get around your object. So I hope that makes sense. We'll open this up to questions now and see how you guys are getting on. But certainly for today's exercise, what we're going to be doing, everything is going to be in third angle projection. And in fact, in general, on engineering design, it's generally third angle projection. But for your e-portfolios, bearing in mind we want to have this as a kind of employability show-off piece that you create. I don't think it does any harm to have some drawings in first angle projection, just to kind of get the difference embedded in your own minds, and so that you can show future employers that you know the difference between the two, and you've got experience of creating drawings in the two ways. So let's just see how you are all getting on, folks. Everyone doing okay there? Any questions? Before the fish tank, Quincy, that was the projection of the shadows. It might be worth sharing the slides again, Ben. What do you think?
I was just about to say exactly the same thing. So let me just get there. If I share now, I hope people can see there, for example, that was where we started earlier, thinking about projections with something that really only has a kind of planar view. So if it's made from sheet metal, for example, you can pretty much define it in one view. But then this is where we started to move towards the fish tank, that there were 3 views that it was useful to look at this object from. We showed the first and third angle projections, and there they are, sort of comparable to each other. And the ways to think about it, so this is back to the fish tank. The first way to think about it is to think about the shadow that's left on the wall of the box behind it, and that is the first angle projection. And then if you want the third angle projection, you have to imagine you're looking through the fish tank and you want to trace out what the shape looks like to you looking through the fish tank. So that's versus third angle difference. And in both cases, you then want to unfold the fish tank. I mean, I guess Alessio and I have both been saying the same thing, which is we don't want people to get hung up on this. You won't be kind of tested on it at any stage in this module. It is quite important to know that there are 2 different standards, and you could come across either of them in your career as an engineer. It's important to know that whether you mean to or not, you are always picking one of those standards, and so you might as well mean to pick one of them. And I guess it's important to know that you can come back to these slides and remind yourself of how to decipher it and how to work out which one's which. Those are the things that I would probably take away, rather than try and remember all this 3-dimensional visualizing, where it's easy to tie yourself in knots, I think.
Yeah. I'd also say once you start working in industry, in many ways, the decision will kind of be made for you. You'll work with particular clients from particular continents, and as a result, that will probably drive which format of projection you're going to be asked to complete in your organization. So it's good to be aware of the 2. I'd go on a hunch and say probably the majority of the work you're going to be doing is going to be third angle in the UK. But there are instances where you are going to have to read, certainly if not produce, other drawings. So whether you're used to first angle or third angle, there will be in your career where you're going to have to read drawings in the other way. So yeah, we're giving you a kind of overview of the 2 types. But yeah, don't get too hung up on working out the specifics of either one, because in all honesty, Fusion does all the hard work for you. So once you've set it to third angle or first angle, those views will be created for you automatically.
There's a question from George saying, is there a quiz today? We are finished with the quizzes now. There were 8 weeks and this is week 9. but I think they've been open, all of them, until today. So I hope some of you who I know people had a tricky time getting onto the VLE right at the start of the semester. So I hope you've had a chance this week to have a go at those. And then we'll do a kind of recap of them all next week, and that'll be it for those quizzes. Shall I now take over? I want to. Oh yeah, Liam.
Oh yeah. With those quizzes, they're all closed now. You said so there's no chance to have a go at them.
Yes, I mean I can reopen them at any time, and I'm certainly keen that everyone should be able to have a go at them. So maybe I'll just leave them open from now on. The way I set them up is that people can have as many goes as they like, but the score that will register, not that we're really too worried about the scores, but the score we'll see will be your first attempt at it.
Okay, cool. Thank you.
I've just got a message saying I've got bad network quality, so I'm sorry if I come across as grainy or crackly, and just let me know in the chat if there's any problems with my network quality. I hope it doesn't affect this class. What I'd like to do next, one of the things that Alessio and I are very aware of, I think, is that assembly modeling, it's useful to do lots of reinforcement of assembly modeling. And then a second thing that's obviously very relevant to today's class is that the kinds of drawings you produce for an assembly they're different things. They're kind of qualitatively different to the drawings you part. And so we want to kind of talk you through that set of things, and also then just how all of that relates to the engineering design process. I'm having a sudden crisis of confidence. I can't remember if I've already been through how to build this particular system in this engineering design class. I know we've had it as a quiz question, but have we had it as a design example?
I don't think so. No.
Good. I can't think why I've suddenly had that panic, but that's fine. In any case, it's never a bad thing to go through things a couple of times. So we'll do that. Sorry, I've just seen a question from Quincy in the chat about the project tool. The project tool for sketching in Fusion is a slightly different thing to the idea of projections, but they both have some overlaps as well. But I think if I do this as an example, we may well be able to use the project tool within that and then see how that goes. So the first thing that I'm going to say, you'll remember this perhaps from the quiz. This system, as it's shown here, actually has a bit of a problem if I was to build it, because I haven't really got any system for fixing the wheels onto the axles. I've designed it in Fusion so that everything turns kind of just like I want it to, but actually, you know, either this wheel is tight on that axle, in which case it won't turn very smoothly, or the wheel is loose on the axle, in which case I'm worried it's going to slide backwards and forwards. So what I'm going to do is build this system, but build it using some bearings, and then that'll be an extra 2 components within the design, and that will then be something that is more, it's more obvious how it would work, and that will tie in when we come back and do the drawing of it at the end. So let's just start from scratch, and there's I've talked a bit about the idea that you can insert components from a catalogue of pre-built components, but I just want to remind people about that. And I will put in some bearings. I guess I'll choose that option, standard ball bearings, metric, and then I'll have a 10mm shaft diameter on my bearing, and everything else I can choose at random. I'm not really very interested here in the specifics of the bearing. I just want something that fits. Okay, so I'm going to say I'll look at the product detail on one of these bearings that I'm being offered. They look like that, which is fine. And down at the bottom of this product detail, I can save that into my model as a 3D step. So that's the process for importing parts from the McMaster car catalogue. We've talked about that before, and there's a video a vehicle using bearings as well that's on the VLE. But I want to make sure everyone is happy enough with that. And what I'm going to do, that's my first component. Actually, sorry, I'm going to cancel that and undo. That bearing looks much more complicated than I want it to. So I'm going to try again, finding a simpler bearing. That one, the main problem that I didn't like was that it had a flange on it, which meant that it didn't just have one outside diameter, it had two, and that is a more complicated thing than I want. Okay, so if I choose that particular size of bearing, I can only have flanged, whereas now I can have standard with a 10mm housing. That's all fine. So again, this looks like the kind of bearing I want. I click on the part number there and I check that it's the right kind of thing, and then I go to product detail, 3D step, and save. And now that looks like a kind of more standard bearing to have in my model. That's the kind of thing I want. And I'm going to say OK on that, just to drop it right at my origin. Then I actually want two bearings. In the end, I've got two wheels that need to turn, so I'm going to have two bearings. So I will right click on that and copy it. And then within the whole model, I'll paste it and drag it out. And I'm going to say I want it 100mm away. That's about the kind of spacing between my wheels that looks fine. I'm not going to worry too much at the moment about the dimensions of things and getting them perfect. I'm just going to do it by what feels about right. Okay, so we've got our bearings in place. The next thing that I'm going to do is to design my axles. So I'm going to have a new component, and immediately I'll call it the axle. And this is the first of them. And I want to sketch that on this face here. Quincy asked about the project tool. And now what I can do, I want my bearing to fit very, very tightly on my axle. And we'll talk in future weeks about tolerancing and things called interference fits, where you're deliberately making two things the same size, so you have to almost bang them together with a hammer, and then they fit very tightly and they won't slip against each other. So that's really what I'm aiming for here, in a sense. And what I can do is to say project the very inside diameter on this bearing, like so, into the sketch I'm doing right now. And then I'll be able to make sure that my axle is sized exactly the same as my bearing. I'm going to finish that sketch now. All I need for my axle at the moment is a circle. And then I'm going to say, OK, extrude. And I'm going to extrude it in two directions, just to, in both cases, meet the front face of the bearing. So one way it'll go to that face of the bearing, I chose to extrude to an object and then clicked on the object I wanted. In this case, I'm going to go to the back face of the bearing. I click to an object and the object I wanted. And now I hope you can maybe see that my axle is exactly the same width as my bearing. And I'll say, OK, that's the axle I want to produce. And the next thing I'm going to do is just to create a sketch on the back of that, use the same center point and come out slightly further. So I'm going to make this, the inside diameter is 11 millimeters. I'm going to make, sorry, it's 10 millimeters. I'm going to make this 11 millimeters. Finish that sketch and extrude the whole thing out. Let's just go 1 millimeter out and say OK. And the important thing now is that my bearing has something that it can rest against on the axle. The bearing can't slide backwards, it can only slide forwards on the axle, for example. So if it's a very tight fit, I can keep on hammering the bearing forward until it sits on that lip on the axle. OK, that's now the axle that I want. So I'm going to go back to the main assembly, copy this axle, and then paste it. And I will move this one 100 millimeters that way, and that should mean it sits in the middle of that bearing. And we'll come back and apply joints at the end, but at the moment I just want everything approximately right. Next, we need the two wheels. They'll both be components as well. I'll start with the small wheel. In fact, I'll call it exactly that. And again, I'm going to sketch just on the kind of central plane of this whole model I'm working on. Again, I'm going to want this to be a tight fit on my bearing, so I'll project in the very outside diameter this time as a circle that I want and say OK. And now that I've got that circle, I can create a small wheel. Now, if I make this about 50, well, in fact, 50 is going to be too big. Let's go with 30. That will do fine. The sizes of things are going to end up being a bit different. Let's just go back. I'm going to edit that sketch. That looks a bit small, so I'm going to make it 50. I was right in the first place. So this is the kind of design process, right? You try something, see how it looks, maybe go back and edit it a bit, change some dimensions. I think this is very much how we want people to be working when they're building up ideas in Fusion. Now that I've got my sketch in place, I can extrude, and I think I'll do the same thing here, where I'll extrude it to make sure it just meets the front face of the bearing, and in the other direction, the back face of the bearing, and say OK. That looks OK. I'm pretty happy with that. So I can go back to my main top level of the assembly and create another new component, and this is going to be the big wheel. This is the same kind of process as I've done a few times now, so I'll go reasonably quick. I'm going to sketch on the XY plane, project in, this time, the outer edge of that bearing, create another circle as the outside, and this time, I guess something like 100 millimeter diameter will work nicely there. Finish that sketch and extrude to be the same width as everything else in my model. think I clicked on the wrong thing there. Twice. I'm just going to cancel and start again since that didn't seem to be working. I'm not quite sure what went wrong. It worked second time around, so I probably did just click on the wrong thing. But again, sometimes that can be the easiest thing to do. If you start getting error messages, just go back a couple of steps and try again, and it often works better. That's all now worked pretty well, and I can say OK. We're quite close now. The next thing that I want to do is actually just to produce, we need these little stubs that the connecting rod is going to sit on there. So I will go back and activate the small wheel because I want to make a new part of the small wheel, sketch on the front face of it, and I can put in a circle here, for example, and make it 8 millimeters diameter. And I guess what I might do, I've just done D for dimension, and I think if I make this 17.5, then that circle is slightly better centered relative to the wheel. I'll say finish sketch, and I'll extrude that circle out 2 millimeters. Maybe we could come a bit further, 3 millimeters, 4 millimeters, and I'm happy with that. Back to the top level of the assembly and just look at things, and now I want the same stub on the big wheel. I'll sketch on the face of it. I'll add in another 8 millimeter diameter circle. I'm reasonably happy with where that sits. Again, you know, I'm doing things by eye here rather than to be absolutely bang on, and I know that I can come back and adjust any dimensions later. Sorry, I clicked sketch, but I meant to click extrude that the same 4 millimeters as before. We now have one component left to build. Actually, just looking at where this has ended up, it's a bit too close to the center of this circle. So if I just go back and edit the sketch that defined that, use D for dimension, and put in that dimension there, maybe I'll make it 40, and then that's now much closer to the edge of the circle. Okay, it's getting quite close, and what I want to do next is to create the connecting rod. At this stage, I could have another 2 bearings and put bearings around these stubs so that the connecting rod can rotate really smoothly. But I'm going to assume it's all right to have the connecting rod have a push fit. And we'll come back and think about that later as well. I'm going to project in, again, Quincy, this is the project tool that I'm using. I've clicked P for project, and then I want those 2 circles available to me in this sketch because I'm going to use them as part of the connecting rod design. And I'll click OK. And now what I can do, I guess the easiest way to create the connecting rod is to use, do you remember last week in the sheet metal, Alessio used something called a slot and a center to center slot. I think if I use that and I choose the centers of those 2 stubs, and then choose some appropriate dimensions like 12.5 millimeters there, I've got a connecting rod that'll work okay for what I'm doing. So it's not quite the same as this connecting rod, which I was a bit fancier with my design, but I'll use this for this demonstration because I think it works okay. I can finally say finish sketch on that, and then the one thing that I haven't done here is to make this a new component, and that's something that I think is tricky to remember about when you're working through these things. So now that I've remembered to make a new component, I will say new component, call that the connecting rod, and then that sketch that I've just produced, I actually want just to be part of the connecting rod and to live within the connecting rod. So I've dragged and dropped it into there. Okay, last thing to do on the connecting rod is to extrude those two features, and we'll go 4 millimeters. So it's the same height as the stubs, and say OK, and that's one solid new body. Okay, that's all the parts made, which is the first part of this. I've still got two things I want to do. The first of those two things is to turn this into an assembly. At the moment, if I just click on this connecting rod, I can drag it to somewhere I don't want it to be. So I'm going to revert that, but what I'm going to try and do is make everything sit exactly within the correct assembly by using joints. One thing I'm going to do under inspect, I can choose component color cycle toggling, and then it'll just give me all the components in a different color, which can be helpful. To make everything sit in the right places, I'm going to start by grounding both axles. That means I can't move those, they're fixed in position. Then what I want to do is, first of all, throughout, I've got everything, the way I've drawn everything here means it's all in the right place already. So I can use as-built joints in this assembly. In some previous examples on the fire truck, we used joints, and we had to be quite clear about exactly how the joint was going to fit together. Here we can use the as-built joint because everything's already in the right place, and that will help Fusion to do a lot of the work about how things are going to fit together. So I'm going to say I want an as-built joint between this axle and this bearing, and I want it to be a revolute joint, and now I need to just choose the axis of revolution. That's the only other information it needs, and if I click there, you'll see the bearing turns like I want it to. Same thing here. I can make the as-built joint between the bearing and the axle. I put the center of rotation right in the center where I want it, and that works okay. I'll keep on going. I'm going to use the same kind of joint between the wheel and the bearing. And we can talk a bit about that if people want, but that looks okay. And again, another as-built joint between the big wheel and the bearing, centered on there. And everything is now turning as I want it to, except that we haven't touched the connecting rod yet, so I need two more as-built joints. The first is between the small wheel and the connecting rod, and this time centered on the center of the stub. And I'll say OK. And the last between the big wheel and the connecting rod, centered on the center of the big wheel stub. If I now start moving things around, you'll see this has got the correct motion in place now. That it can only move so far on the big wheel, just like in that quiz question about it, but the small wheel can rotate the entire way. and I can hide the joints, and then that is the assembly that I wanted to create. It doesn't look exactly the same as this original assembly that I was working from, but that's fine. It has the same motion, and that's really what I'm interested in. This time I've been able to use bearings within it, so I'm more confident that I can show somebody how this would actually work. And I'll come back and think about that when we do the drawing. So I'm going to save this as the new connecting rod assembly. In fact, let's go connecting rod assembly V2, just so I don't have too many things saying new if I do lots of multiples of it. And then what I'm going to do is the same thing that Alessio did with the part model earlier in this drawing, and turn it into, earlier in this lecture, and turn it into a drawing from the design. I'm going to accept all the defaults and see how that looks. I'll slow down a bit now that we're doing drawings, which is really the center of today. So I'm going to accept all these defaults. I think I've set up my standard template so that I'm using third angle projection, just like Alessio showed. And so I'm happy with what I've got, and I'll say OK. And again, just like Alessio said, we need to be a bit patient. And then I'm going to bring this in at 1:1, at full scale. And I'll place it in the middle of the page there and say, OK. One of the things that we've hinted at that I'm now going to say more clearly, an assembly drawing is quite a different thing to a part drawing. A part drawing needs to show somebody else how you would actually make a specific part. And that's got all kinds of details, like where would they have to position the drill bit, or what size of cut would they have to make from their initial material. That's what a part drawing needs. An assembly drawing assumes that you have all the parts already. So here, what I need to show somebody is what are these parts and how do they all fit together. And so I can use this particular view that I've got here. It'll probably be okay. But if I really want to make it clear to somebody, maybe another thing I can do is to put in a projected view. And I'm going to project up that way and hit return. So I've got my projected view, and then move my projected view into somewhere where I want it to be. And I'll just move this one down so that it's slightly clearer what the relation is between the projected view and the side-on original view. Again, this is something you probably do more of with an assembly, where you're not going to have to dimension it so much. And in fact, in assembly drawings, typically you won't have any dimensions on them at all. So these kinds of isometric views can be much more useful. They're harder to dimension, but they sort of give you a better visual representation. So that can be a good idea in an assembly drawing, is to put in an isometric view. Then the other things that I really need to do are to tell people what all those parts are. So in Fusion, you go to tables here and click table. And then you can see I've got a table which I can move around the drawing. I'm going to put it up here. And everything gets automatically filled in by Fusion. So we've got a parts list now that explains what everything is, and we've got these numbered parts on our view on the right-hand side. If I want, just like with anything else, I can move the number bubbles around by clicking on the grey arrow, and I can move the place they point to around. So if you think that'll help to make things clearer, you can do all of that. You'll note that we've got 2 bearings and 2 axles, and only one of each is numbered. I think I can put on another balloon, and if I want to go there, then now both my bearings are numbered, for example. So that's a thing I can do if I want to make it absolutely clear, and I'm worried that the person looking at the drawing might not know where these 2 bearings are. I can number them both. Within this table, I can double click and I can turn some things on and off. So instead of part numbers, that's not quite right. What I'm actually showing is part names. Fusion is giving me the same things twice if I choose part number and part name. So I'll call that part name. But this is the kind of place you would want to kind of play around and see what worked. The next thing that I'm going to do is to close this for now, and you'll see 2 of the options that we're being given are, first of all, to do with the material. We can see the material for each part, and secondly, to do with the description. And I just want to show you how I can include those in the table. They both actually come from the original model. We've talked before about how to change material, so we'll start with that. Because the connecting rod doesn't have bearings, maybe I might want to make it out of a slightly softer material so it'll fit on the stubs more easily and rotate more easily. So let's say I'm going to change the physical material of the connecting rod. I'm going to make that nylon. My software catches up, so I can drag and drop nylon 6 onto that rod, and I've now got it as a different material. So that's the first thing I can do. If I just turn off the component color cycling, then you can see this has given me a different appearance for the nylon example to the steel bits of the model. And then the other thing that I might want to do, this is not a very informative description, 5972 K211. So I can add in a description there by going to right-clicking and going to Properties. You'll see here an option to add in a description. So I'm going to say this is a bearing from McMaster car and say OK. Now I'm hoping that because this second bearing is a copy of the first, that will copy across, and in fact it does. So that's quite nice. That's all worked as I expected and hoped it might. OK, so I put in a description of something. I've changed a material. Now I'm going to save my original model. I'll call it description plus material, just so I know where that save point is. I can go back to my drawing, and now you'll see this information with a kind of yellow exclamation mark up here that says you've got some out-of-date references. And I think if I double click on that, it'll update all my references. And now you can see in the table, I've got a clearer explanation of what this part is, and I've got the new material for the connecting rod. The last thing that I want to say, I guess I'll save this drawing using the default name. I would put in, of course, all of the things that Alessio showed about things that I can put into the information, the title block, the information box down here. I guess another thing that I might do, because I'm trying to make sure somebody else can make this really easily, is to add some text saying all connections are push fit interference fits. And what that does is it tells people, for example, they don't need to worry about glue. You know, people might look at this and think, should I glue together some of the components? That instruction would just say, no, don't do that. The very last thing that I want to look at is, once I've built this assembly and I've got my assembly model of how everything's going to fit together, I still need to get someone to build all of the parts that aren't coming from McMaster Carr. And so for each of those now, what I would do is to right click and say create drawing from each of the individual components in my model. The axle can probably go on an A4 sheet. Now I'm doing exactly the things that Alessio was doing earlier on. I'm just producing a model with the correct projections. And then I can add in dimensions and work just like we did with part models at the start of this tutorial and this lecture today. So that can be a useful workflow, I think, and it's something that people might use for some of their engineering design projects, where you design a series of components as you go through the Fusion model. You produce a drawing of the whole assembly, which is really there to show people how things fit together. And then you produce individually dimensioned drawings of each component that goes into the assembly. Because I've got two axles, I wouldn't bother producing two drawings for two identical parts. It should be clear to anyone who's working with me that we're producing the same thing off the same drawing twice. And again, I just go on and make this a better drawing using all of the same kinds of first of all, we've talked about a way of producing a moving model based on a whole load of components, but working within one Fusion model. Then we've talked about how to put joints in between all of those components so that the motion is correct in your Fusion model. And then we've talked about how to produce a drawing that shows how everything fits together. I saw a hand go up. Do people have questions and feedback on that? Okay, I'm not seeing or hearing too much at the moment. I mean, I guess because we've been through assembly modeling once, you know, that all went slightly quicker than the first tutorial on assembly modeling and all tutorials on part modeling. But I hope people got a good sense of the process there, and I hope you can now go away and use similar ideas in your own work. Alessio, I'm getting a bad video quality message again, so I hope it's not too crackly. I wonder, I'm just going to go back and look at the spreadsheet on Teams and see what the take-up has ended up like for face-to-face tomorrow.
Sure. Do
you have anything that you want to add in? Yeah, sorry, I'll shut up.
Oh, sorry.
No, it's fine. I'll shut up.
While Ben is checking that, everyone, just an FYI, so many of my project students in the final year, and I know for other supervisors, they will be asked to create a full set of 2D drawings for some of their final year project. So while this varies from project to project, please bear that in mind that this is a really valuable skill for you. And you may be asked to do this as part of your final year project, your 40 credit bearing project module. The other thing, Ben, that I just wanted to, well, first of all, thank Dewey again for. We were provided with a really helpful link that Dowie had come up with, he'd found online, so thank you, Dowie, for that. So if you want to challenge yourselves to model a few additional things in Fusion, there's an additional free ebook that has about 30 modeling exercises for you, and you can find that in Fusion 360, part modeling from engineering drawings. And it's just a fantastic resource. So yeah, thank you, Dowie, for finding that. So if you want to just push yourselves in terms of reading an engineering drawing and then modeling something from that 2D drawing, or even the other way, create the 3D part and then create the corresponding 2D drawing. That ties in quite nicely with what we've been talking about today. I'm just going to check. Ben, are you still with us?
I'm back, and the sign-up sheet is still the same as it was with 3 sign-ups. So I think it's going to be better if we don't run with 3 students. It's just a better experience for everyone with a more full classroom. I'm sorry to the 3 students who did sign up. I think that's Ali and Berzan and Juliet. So I'm sorry about that. But we will run the same class again next week, and we hope we'll get a bigger take up on that face-to-face class, and then yeah, it'll be a better experience, I think, with more people in the classroom.
Yeah.
So I think that's now confirmed that tomorrow's face-to-face class is cancelled for lack of interest, and rescheduled to the 25th, I guess.
I've noticed Berzan isn't here, so I don't know if somebody could just reach out and let him know. Juliet, sorry to put you on the spot. Is that something you might be able to do?
Yes, I'll let him know.
Thank you very much.
Thanks, Juliet.
No problem.
That's really helpful. Okay, that's now coming to the end of the class. I know that there was a question earlier about, I think it was going to be about FEA, but nevertheless, it's all connected to engineering design. So I think we're happy to look at that in this class now. Before we do that, though, do people have any kind of questions or things that you want to raise about this engineering design class? Good. I'm just finding a couple of exactly the question that I was hoping I might just be about to answer. If you go to this VLE page, Stephen, I think that'll link through to a page called Part Modeling from Engineering Drawings, and then at the bottom of that page, there's a link to the ebook. That's the one we've just been talking about. And it says, thanks, Dowie, next to it, just in case we try to take credit for that ourselves at any stage. And then the other thing that I just wanted to make clear is that there's a page on the Moodle site, just for anyone who wasn't there at the start when we mentioned it, which is called, sorry, my Moodle's just being slow. It's called Fusion 360, Engineering Drawings and BS 8888. And that contains the slides from today, and also some part files which you can use if you want to make the assembly we looked at in the second half of the lecture. So that's there for people who are interested in that. Maybe just for 2 minutes before we go, what I might do is just show you on my screen some of the other things that we'll come back and keep thinking about in this module from that set of slides about engineering drawings. This is where we got to, looking specifically at different projections. But also there are things within here like the convention for drawing ribs and thin material, for example. There are conventions for threads if you've got bolts and anything threaded, including internal threads. There are conventions for gears. And you'll be able, lots of different kinds of gears. Again, all of them have specific ways that they're typically drawn in BS 8888 and springs. And then one of the things that we have touched on, but that we'll come back and think about again, is just good practice around dimensioning things. Sometimes if we're not careful, we end up with the same dimension on a drawing 3 or 4 times, because you know, if you dimension on this example on the screen right now, from the left-hand edge to the center of the left-hand circle, and then from the between the centers, and then from the right-hand circle to the right-hand edge, and you dimension the whole block, you've got the same information repeated twice. So, you know, we'll talk a bit about ways to be careful with that. And then the last thing that I wanted to just mention again before we stop is, sorry, the slide deck is so big that it goes slow for me. Tolerances, and tolerances are about how things fit together very closely, and they need to be made to a particular size. And so you're telling the person who is making something for you, this needs to be correct to within 1/10 of a millimeter or something like that. And you'll all have seen tolerances and worked to tolerances in Introduction to Mechanical Engineering last year. When you made your whistles, those are all toleranced in various ways. So we'll just talk a bit about, first of all, how to make sure you're doing that right within your own designs and how to get that onto your drawings. But we'll do that in future classes. I've just seen Alessio's comment in the chat. Yeah, it's a very good resource to have. So do get onto the LSBU website and try and find that standard.
We were sort of forced to buy it, so it stuck with me that we were forced to pay money for that, and the fact you can all get that for free now, folks, it's a good thing. So you may never use it in your future, but I think it's one of those things that it's very useful to have. I'd rather have it and not need it than need it and not have it, and then have to shell out for a British standard, which are not cheap documents.
Okay, I think.
I have a question.
Yeah, Manju.
It's not about the class, but it's the update about second semester.
Yeah.
So is it gonna be online or is it gonna be like face to face? That's the question.
There is no change from what we said last week on this. So the answer is, at the moment, we're planning for different scenarios, and the kind of middle and most likely scenario is the same kind of hybrid as this semester. But again, things change so quickly that it is almost certainly going to be different from the scenario we're planning for. You'll all have seen, I hope, that there's been good news about vaccines twice in the last couple of weeks, and that may mean we can do more in-person and face-to-face work, particularly, I think, trying to go back into the computer rooms so that we can, work with you on your fusion work would be a lovely thing to do. But we've had no confirmation from the university or from the government that that's going to be possible, and so we can't guarantee it. Alessio, anything to add on that?
Not really, Ben. Just that I suppose we share your concerns. We'd like to know as well. If you can imagine, as a lecturer, it helps us a lot if we knew whether we were on campus or whether we're teaching remotely. So we're all in the same position, in different ways, of course, but we're all in the same position. The one thing we do promise is, as soon as we know, as soon as we hear, we will share that with you. And I'm sure you'll get notification as well through the provost's emails to you. So he'll be clarifying that. But as and when we hear things, we'll keep you all updated. But we share in your concerns and frustrations. In an ideal world, we'd know exactly where we stand in January and February, but we don't. So we're having to cater for all scenarios at this point, just in case, just as a backup.
And I suppose the other thing is that, of course, we know one of the things that students have said is communication is really important. And so we want to be communicating, but it doesn't seem very helpful to send out a new email every week saying there's no change in the government policy, so there's no change in our expectations. So, this is actually a really useful thing for me and for Alessio, because we can talk to you in this class and kind of do it all in a less structured way to say, I'm sorry, but this week there's no change. And, it's absolutely fine for people to keep on asking us and keep on talking about it in this class. And that's a good way to get the communication done, I think. But as Alessio says, once there's real concrete information we can work with, you'll almost certainly hear it in a number of different ways. There's a hand up, I think, from Knife.
Yes, I have a question about coursework 1.
Yeah, sure.
Yeah, the submission is in December 4th.
Yes, yeah, the hand-in is Friday, December 4th, yeah.
There is no extension for it, right?
No.
No.
We need extension. No, huh?
You've still got, I guess, what's that? 2.5 weeks.
I'm just asking, that's it.
Yeah, and we don't think there have been any circumstances that have come as a surprise during the length of the coursework that would lead to an extension. So at the moment, no extension. I guess it's useful to say there as well. We choose that that submission point on the 4th of December because you'll find, well, you've got exams in January, and also there will be a number of submission points in week 13 in January. And because this module is what's called long and thin, it runs through both semesters, we don't have to pile things up in week 13 in January and around the exam period in January. So we move all of our assessment points to be away from that exam period to give you a bit of a balance of where your modules are requiring work. So that's why I think you'll find neither of us are that keen to move that assessment point later, because it will make things more difficult for a lot of people, because it'll start to run into your solid mechanics and FEA work, for example. I think what we'll do, I'm going to stop the recording and say that this class is finished, but I know Zia wanted to talk about that question on a fusion model and the meshing for it. So we'll stick around and be free to, I'm happy to talk about that now, but people can stay if they're interested, but otherwise I think we can say this class is over, and thank you all very much. We're sorry we won't see you face to face tomorrow, but we will see you next week, and we'll keep talking about similar things and also try and give some kind of direction where people need it around coursework 1, because that's going to start to get towards the crunch time. Thanks all, and Zia, if you want to talk to us about the problem you were having, then you go ahead and do that. Thank you.
Thank you, Ben. Should I share my screen with you?
Yeah, if you can, that's great.